So hello everyone, today I am here to explain about the program number 6 that comes under Ddco Lab-06, that is designing of a Verilog program to implement different types of multiplexers like 2:1, 4:1 and 8:1. Now let me define about multiplexer. So when it comes to multiplexer, our definition says that a multiplexer is a combinational circuit that has 2 power n input lines and a single output lines. So this means that a multiplexer always consists 2 power n input lines and the single output line. So it means when we consider a multiplexer, we can say there will be multiplexers like 2:1 multiplexers, 4:1 multiplexers, 8:1 multiplexers and so on. So and then a multiplexer is an electronic switch that connects one out of n input to one output. So in general case, we use switch to join the wires. So let me explain about this point. So now, so these are the input lines and I name it as I1, I2, I3 and I. So we know that in multiplexer there will be only one output line. So I have considered it here. So in this statement, a switch word is used. Now let us see what is the meaning of that. So if I consider this as a switch and join this wire, then input 1 will be selected as the output. So similarly, if I join I2 through this switch, then I2 will be selected. So in multiplexer, at a time only one input will be selected. It is functionally complete, that is all Boolean functions can be realized using one multiplexer without any other gates. So it is one of the most important point because a multiplexer can be used to design any of the logic gates as well as logical circuits. So now let us discuss different types of multiplexers. So we know that in multiplexers there are 2 power n input lines and 1 output line. So here I have considered 4:1 multiplexer. So I have considered 4 input lines and named it as I1, I2, I3 and I4, and we know that multiplexer always has only one output, that is F. So now the question is, among these input lines, so which will goes for output? That is, which among these will be selected as output? So here we need to consider the select lines. So how to consider select lines? So here we know that 2 power input lines and 1 output lines. This n represents the select lines. So as here n is 2, so I am considering 2 select lines, that is S0 and S1. So we know that we can represent 4 using 2 bits, that is 0, 0, 0, 1, 1, 0 and 1, 1. So now I am sending these inputs to the select lines. So if I send 0, 0, then input 1 will be selected as the output. So if I send 0, 1, then I2 will be selected as output. If I send 1, 0, then I3 will be selected as output. And if I send 1, 1, then the I4 will be selected as output. So we can represent these multiplexers in Boolean expressions like S0 bar, S1 bar. That is, if I send 0, 0, then input 1 will be selected I plus S0 bar, S1, then input 2 will be selected plus S0, S1 bar, I3 will be selected. So we can say that for 4:1 multiplexer, it is a Boolean expression. So now let us see 8:1 multiplexer. So we can represent 8:1 multiplexer as 2 power 3:1. So now how many numbers of select lines will be there for 8:1 multiplexer? So as their value is 3, we use 3 select lines, that is S0, S1 and S2. So or we can say, as there are 8 input lines, so we can represent 8 using 3 bits, that is, so if I select 0, 0, 0 and send it for select lines 0, 0, 0, then input 1 will be selected as the output. So similarly, if I send 0, 0, 1, then input 2 will be selected as output. So similarly, it goes on, and if I send 1, 1, 1 to the select line, then input 8 will be selected as output. So we can represent these also using Boolean expression. 2 is to 1 multiplexer. So in 2 is to 1 multiplexer, it is very simple. There will be only one select line, that is S0. If we send 0, then input 1 will be selected as output. If I send 1, then input 2 will be selected as output. So it is 2 is to 1 multiplexer. So now let us see how to implement these three multiplexers in a Verilog code. We have learned what is a multiplexer and different types of multiplexers such as 2 is to 1, 4 is to 1 and 8 is to 1 multiplexer. So here we are implementing those multiplexers using a Verilog code. So first we are implementing 2 is to 1 multiplexer. So here is a code for 2 is to 1 multiplexer. So we know that in 2 is to 1 multiplexer, there are two input lines, one output, and there will be one select line. So I have declared mux as the module named for this 2 is to 1 multiplexer. And I have used S, D and Y variables, where S represents the selector input and D represents the data input and Y represents the output. So in second line, I have declared S as a single bit input signal. So although 0 is to 0 is unusual, it still defines a single bit. So in third line, I have declared D as a 2-bit input signal, where D of 0 represents the first bit and D of 1 represents the second bit. So as we all know, when we consider any multiplexer, there will be only one output. To represent that output, I have used Y. So in fifth line, a reg Y is used. So it declares a Y as a register which allows it to hold values. So since Y is assigned inside a always block, it must be defined as a reg type in a Verilog. So it is very important because we are using reg Y. Since Y is assigned inside a always block, it must be defined as a reg type in a Verilog code. So when it comes to 6 lines, always at S or D is written, which defines an always block that executes whenever there is a change in either S or D. So the block executes its logic whenever the selector S or the data inputs D is changed. So we know that when we consider any multiplexer, only one input will be selected as the output. So that's why we are using cases here. So case of S is used because it begins a case statement to decide the value of Y based on the value of S. So in 8th line, a 0 is to Y which is equal to D of 0 is used because if S is 0, assign the first bit of the D, that is D of 0 to the output Y. When we send a 0 to a selector pin, then first input will be selected. So in line number 9, that is 1 is to Y is equal to D of 1. So which represents, or I can say, if S is 1, assign the second bit of D, that is D of 1 to the output Y. So it tells that if I send the 1 to the selector pin, then input 2 will be selected as the output. And finally, I have ended the case and ended the module. So here you can see the output for the 2 is to 1 multiplexer. When it comes to 4 is to 1 multiplexer, so we all know that there will be 4 input lines and a single output lines and a 2 selector pins. So we are considering 2 selector pins because we can represent 4 is to 1 multiplexer as 2 power 2 is to 1 multiplexer. So as the power value is 2, we are considering 2 selector pins. And the one more way to consider a selector pin is we can represent 4 using 2 bits. So hence we are considering 2 selector pins. So as you can see, here is a following code for 4 is to 1 multiplexer. So here I have declared module named mux with 3 ports, that is S, D and Y, where S represents a selector input and D represents a data input and Y represents an output. So when it comes to second line, I have declared S as a 2-bit input signal, and it allows 4 possible combinations such as 00, 01, 10, and 1 1, which are used to select one of the 4 inputs in a D. When it comes to third line, I have declared D as a 4-bit input signal. The 4 bits of D are D of 0, D of 1, D of 2 and D of 3. Where D of 0 represents a first data input and D of 1 represents a second data input and D of 2 represents a third data input and D of 3 represents a fourth data input. So as you all know, when we consider a multiplexer, there will be a single output. So to name that output, I have considered Y. So when it comes to fifth line, a reg Y is used. The purpose of using reg Y is it declares a Y as a register to hold the values. So since Y is assigned inside an always block, it must be declared as a reg. So that's why we are using reg. So when it comes to 6 lines, always at S or D is used. The purpose of using it is it starts an always block that triggers whenever S or D changes. So this ensures that the output Y is updated whenever there is a change in the selector S or the data inputs D. And then some of the cases are used because when we consider a 4 is to 1 multiplexer, as we all know that there will be 4 input lines. So hence there are 4 possible combinations for input, or we can send 0 0 or 0 1 1 0 or 1 1 to the selector pins to select an one among 4 inputs as an output. So here are the following cases, that is 0 is to Y is equal to D of 0. And its purpose is if S is 0 and the binary value of 0 is 0 0, the output Y is assigned the value of D of 0. And next 1 is to Y is equal to D of 1. The purpose of it is if S is 1, the output Y is assigned the value of D of 1. And the next 2 is to Y is equal to D of 2. The purpose of it is also if S is 2, the binary of 2 can be is 1 0. The output Y is assigned the value of D of 2. And 3 is to Y is equal to D of 3 is if S is 3, the output Y is assigned the value of D of 3. Finally, I have used the end case. The purpose of end case is it ends the case statement. And the end module is it marks the end of the module definition. When it comes to 8 is to 1 multiplexer, we know that there will be 8 input lines, 1 output lines and 3 selector lines. So we are considering 3 selector line because we can represent 8 is to 1 multiplexer as 2 to the power 3 is to 1 multiplexer. So as here power value is 3, we are considering 3 selector lines. So or one more way to select the number of selector line is, so we can represent 8 using 3 bits. So hence we are considering 3 selector lines. So here is a code for 8 is to 1 multiplexer. So code is same as that of 2 is to 1 and 4 is to 1. But the statements which comes under the case changes because in 8 is to 1 multiplexer there are 8 input lines. So then rest all part is same as that of 2 is to 1 and 4 is to 1 multiplexer. So now we are going to see the output for 8 is to 1 multiplexer. So here is an output for 8 is to 1 multiplexer. I hope that all of you got understanding about the multiplexer. So thank you one and all.